Hello everyone, in today's video we're going to be having a look at a probability question. Now this is a continuation of the final exam preparations. After this you're going to be getting a series also as well of probabilities where I break down each and every part of the probabilities. So if you are new to the channel, I'd like to welcome you, and also to the ones who are returning, I'd like to thank you so much guys for coming back. And also don't forget to always share this to your friends, and also if you like the video, like it. And also if there's anything that you would like to request, leave that in the comment. And lastly, don't forget to subscribe so that you won't miss when the video gets uploaded. So let's go ahead and dive right into the questions here. So we have 1.1, 1.2 and 1.3. 1.1, it goes as follows. At a school, learners may choose subjects from one of the following streams: commerce, science, or humanities. Now, there are 100 learners in grade 12 at the school. Now, their choice of subjects is summarized in the table below. All right. So now here in this first question here, I think it's best that I actually write what it is about. Right. So here we are focusing on a table. Right. We're going to be using a table. Okay. Now let's go ahead and start with the first question. Let me just use, I like using these colors. Let me use this one, 1.1.1. All right, so the first question, it says calculate the probability that a learner chosen at random from this school, right, or from this group is a girl, right? So we're looking for the probability that the learner chosen is what? Is a girl. Now, how do we basically calculate that? Now, to use the diagram, we need to find where do we see the part written girl, right? And in this case, we can see this is where girl is, right? Now, here there are 8 girls doing commerce, 20 girls doing science, and 22 girls doing humanities, but all in total, there is 50 girls. So this then means now the probability that we can get girls in that group will be the event, which is 50 girls in the school divided by the outcome, which is the total number of learners, so which is going to be 100. Now when you simplify this, it gives you 1/2, or you can just write it as 0.5 or 50%. All right, so depending on how you write it. Okay, so let's go ahead and look into the second question. That one was quite easy, so let's look into the second question. Second question, it says calculate the probability that a learner chosen at random from the school, right, or from this group has chosen science. Okay, so now which means now here, in order for us to answer this question, remember at first it said group is a girl. Now it says group has chosen science. So which means now we need to look at where we need to look at science. So that is the key word. So this is science. Now there's 15 boys who are doing science, and there's 20 girls who are doing science. It means in total there is going to be 35. So which means now the probability for this one will be the probability doing science. So S will stand for science. The event of this will be 35, and then the outcome will be 100, right? So now here, when you simplify this into a calculator, using a calculator, we will then have 35 over 100, so it will be 7/20, right? So we're getting 7/20. That will be our answer. If you want to write it in a percentage, of course you can do that by changing this into the common, like into the decimal, sorry, yes, a decimal. So that way you write it as 0.35, so that is basically means 35%. All right, that was easy. Now let's go ahead and look into the final question of 1.1, 1.1.3, right? Now the question here, it's saying, are the events being a girl and choosing science independent, right? All right, so are the events being a girl and choosing science independent of each other? Now it says we need to justify our answer. Now the question here, or the hint here, it is the word independent, right? Now what does that mean? So it means now when you take a probability of girl and intersect it with a probability of science, that should be the same as a probability of a girl multiplied by the probability of science, right? So this means independent. All right. Now, if this is not equal to that, then it means they are dependent to one another. Basically, that's what this means. Okay, so now here already I know what is the probability of girl and the probability of science. So the first thing that I'm going to do is I'm going to calculate what is the product of these two. So I have 0,5 for girl, multiply 0,35. So now I can take out my calculator. So here already there's 0,35. I can write that first. Doesn't matter, but as long as I multiply both of them, and then I get 7/40. So I get 7/40. Do I need to write this as a decimal? Again, no. But then now after this, I need to look for the probability of n intersecting g, right? G intersecting s, sorry. I said n intersecting g. So it's supposed to be g intersecting s. So g intersecting s, it means this is where I'm looking for a girl that is doing science, right? So where do I see a girl doing science? If you remember, to do that, I'm going to go to science and go to girls, and then I'm just going to draw a line like this, the easy way to do it, up until the end, and then you draw another line up until the end, right? And then from there, you're going to look for where these lines intersect. So as you can see, this is where they intersect, right? So this then means now this is your probability, or this is the event of a girl and a science, or girl intersecting science. So in this case, it is 20 over, now the total, remember, the total, it is still 100. So it is 100, and then now this is 20%, or you can say it is 1/5, which is 0,2, which is 20%, right? But then now notice that 1/5 is not the same as 7/40, right? So this means now the probability of G intersecting S is not equal to the probability of G multiplied by the probability of S, right? Now, therefore, the answer is no. They are not independent. All right, so now we're going to move on into the next part, which is 1.2. Now 1.2, it is mainly focusing on counting principle, right? So I'm just going to write it as a counting principle, principle. So 1.2 and 1.3, they're more or less like the same. So this is grade 12 stuff, right? So let's go ahead and read here. So here the question, it goes as follows. Now, how many 4-digit codes, right, will be formed using digits? So 0, 1, 2, 3, 4, 7, and 9, right? Now consider the following conditions. Okay, so now here, first condition, it says the code must be an even number, right? So it means it must be divisible by 2. The second condition, it says the first digit must be less than 4. And then the last condition says digits may be repeated. All right, so now how do we then decide for this question? So the first thing is to look at what are we trying to do. So here we're trying to do a 4-digit code. So here this is a 4-digit code, 2, 3, 4, right? So now we're trying to find a 4-digit code. And then now how many digits are we trying to use? So here we're trying to use 1, 2, 3, 4, 5, 6, 7 digits, right? So it means in total we have the total. Let me just use a different color for this. Something's going to be brighter. The total digits that we're trying to use here, it is 7, right? So now the main focus here, it is to always focus on the total number of digits, but also be aware of how many digits we'll be filling in these instructions there, right? That will fit in this instruction. All right, so let's start off with the first instruction. So the first instruction, it said that the code must be an even number. So a code being an even number means now the last digit must be divisible by 2, right? Or it says here it must be divisible by 2. Now a number, in order for it to be divisible by 2, it means that the last digit of that number must be an even number, right? So now here, which means now we need to go and look at the list that we have here. So this is our list. Now how many digits here that we know that are even numbers? So it is 0, 2, and 4, right? Now there's 3 digits there. So what does that mean? So this means now we're going to have then 3 options towards the end of our code. So this 3 stands for the options that we're going to be having. All right, so we are done with the first part. Now we're going to look at the second part. So the second part, it said the first digit must be less than 4, right? So the first digit, if we're saying we want it to be less than 4, it means we need to look for all the digits, or we need to count how many digits that are less than 4. So now here there is 4, so I have 3, 2, 1, 0. So those are 4 digits, right? So which means now here I have 4 options to put in there, because there's 4 digits that are less than what? That are less than 4. Now the last part, so this one we're done. Last part, it says digits may be repeated. Now when it says digits may be repeated, it means that we can use the digits that we have already used here and the digits that we have already used there. Now if we're repeating the digits, it means we can use all of them basically, right? Now how many digits do we have? We have 7 digits. So that basically means now here, whatever number that we put in here, we will have 7 options to put in a digit there, and as well here 7 options to put a digit there. Now to write now what the digit codes, or to find out how many digit codes we can have here, all we have to do is to multiply everything together, right? So now we then going to equate this, and then we're gonna go into our calculator, and then into our calculator we will then press 4 multiply by 7 multiply by 7 multiply by 3. Then we're going to get 588. So this 588 is going to be 588 ways or digit codes, right? Or 588 4-digit codes, right? So that is going to be the answer for 1.2. Okay, so now let's move on into the final one, which is 1.3. All right, so I also like to call this one a counting principle, because we are still using counting principle, but then now we're focusing mainly onto into letters, right? So let's go ahead and read the instructions that we have here. Right, now the letters of the word leopard, right, are randomly arranged into a different 7-letter word, right? Now it says letters may not be repeated. Okay, so now here we are working with a what? A 7-letter word, right? So which means here we're using those digits, but then those digits must be in the 7-letter space. So I'm just going to draw 7 lines there, so that I can give you the solution as the question as we actually reading the questions and answering them. All right. So now here it says letters may not be repeated, right? So the first thing that we need to do here is to actually kind of calculate the total digits, right? To understand how many digits do we have there. All right, so now here we have 1, 2, 3, 4, 5, 6, 7. So that is 7 digits. So we have a total of 7 digits. So now which means now we will have 7 digits to just to put it all over there. All right, so now let's go on and look at the first question. So the first question, 1.3.1, it says, in how many different ways can the letters of this word be arranged? All right, so now here, because if we have 7 words and then letters may not be repeated, if we put in the numbers, the letters here we'll have 7 options, and once we use it we'll have 6, and once we use that we'll then have 5, right? And then after using that we'll have 4, and then 3, then 2, then 1, right? So basically this is the same as saying 7 factorial. So it means now the total here it is 7 factorial, right? So this is the total if we just put everything just as how the instruction have said it, right? Okay, so now let's move on into the second question, 1.3.2. So now it says determine the number of different ways in which a word formed will start, right, with a vowel and end with a consonant. All right, so now here let's go again and open up our 7-digit space. 1, 2, 3, 4, 5, 6, 7. So now we need to think through of how we're going to be doing this. So now here it's saying here we need to find ways, right, in which the start of this word will have a vowel. So let's go ahead and do that. So now in order for us to do that, we first need to look at the vowels here. So how many vowels do we have here? So we have E, O, and A, right? So those are 3 vowels. So this means now here in this word, we'll have 3 options to put in there, right? Okay. And then on the second part, it said this word must end with a consonant. So I'm going to underline that, and with a consonant. Now, what are consonants? So basically, anything that is not a vowel, we consider it as a consonant. So how many consonants do we have there? So we have 1, 2, 3, 4 consonants, right? So which means now right here we will have 4, right? Now, get this now. Remember here, letters may not be repeated, right? So letters may not be repeated. So now here we used one of these 3 consonants, right? If you're generating a word, it means you're going to be using one of these 3. So it means we're going to be down with 6 letters. And then after using a consonant, one of the consonants there, you're going to be left with what? With 5 letters. So this means now here, we can then play around with those 5 letters. So that then means that here we'll have 5 options to put the letters, then 4, then 3, then 2, then 1 letters, and then that will be our final answer. Now to get this into our answer, it's going to be 3 times 5 factorial times 4, right? Okay, so now going to our calculator, we'll have 3 times. Now to write a factorial, you press 5. Well, we actually want to find 5 factorial, so I have 5 then. So if I want to put a factorial, I need to press shift and press this button here. Notice that it will give me that factorial, but then I need to multiply this by 4, and then that is going to be my answer. So it is 1440. Okay, so now let's go ahead and move on into our third question. So 1.3.3, right? So the question here, it says calculate the probability, right, that in the different, okay, let's start over. Calculate the probability that in the different words formed in 1.3.1, all vowels, right, will not follow each other, So basically here, they want us to calculate the probability where all vowels may not have a chance, or a chance actually of following each other. All right, so now how do we do this? Now this is one of the most questions that people, they find it incorrectly. This is basically what we call the complement rule, right? This is what we call the complement rule, because firstly, we don't know whether when we put in these values they follow each other, right? So which means now we need to use a complement of this, right? So the complement rule, right? Okay, so the instruction here, it's saying what? It's asking for the probability that in the different words formed, all vowels, I'm going to underline that part, all vowels will not follow each other, right? Now for us, it is impossible for us to understand that, right? But then what we can then do to actually find this is to ask ourselves, okay, so if the question is asking for a probability in that in these different words formed in 1.3.1, all vowels will not follow each other, let's then first consider what will happen, right, when these vowels follow each other, right? So now the question again is asking what? It's asking that, it's saying basically all vowels will not follow each other. Then now the complement of that, in order for us to get this, is to ask ourselves, what is the probability, right, that they will follow each other, right? So I hope that you understand that. So in order for us to do that, right, in order for us to do that, let me just say here, the idea, the approach, let me write approach here. Our approach is that we say we're going to find a probability, right, that all vowels follow each other, right? Yes, the question is asking probability that they will not follow each other, but then now we're asking each other basically what is going to be the probability of them following each other, because it's easy for us to do that, right? Now how are we going to be doing this? So this is how we're going to be doing it, right? So now here, number one, if they follow each other, it means now they are grouping, right? So we're gonna have a group of vowels, right? If they're following each other, right? So now how many vowels do we have there? Remember, we have 3 vowels, right? So we have E, O, and A. So we have three of them. So now if they follow each other, it means we're gonna consider them what? A group, right? Now by considering them a group, it means now we need to actually find out the ways that we can arrange these vowels, right? So now we have three options. So if we are arranging these, right, we can have three options there, then two, and then one. So this basically means now as a group, it is going to be, right, 3 factorial, right? Now, the question, it wants us to keep these vowels as they are, right? Like that, right? So now because of that, right, we're gonna then treat the group as a letter or as a single object, right? So now we're gonna treat the group, right, as a single letter, right? Now when we treat them as a single letter, what does that mean? So it means all that group of vowels, right, will act as one letter, and then we'll have L, P, R, and D as letters that we're actually arranging around, right? So how will this look like? Just to give you an idea. So this is how it would look like, right? So let's say maybe we're choosing E O A as our order of writing the vowels. So now in our seven letter, it will look like 2, 4, 6, 7. It will look like this, right? So we'll have a word that will say E O A. Now notice that this is a group, right? And then from there, it will then arrange L, P, R, D, right? But then now these ones, they act as a single, right? Or as a singular, like that, right? So that is basically what I mean by saying you're gonna treat the group as a single letter, right? Now, if you notice here, this gives us a total, right? This gives us a total of 5, right? Or we can say, look at it as 5 groups instead of letters, right? I think it's easy maybe if I can say treat the other letters as a group, right? I don't know if that makes sense, but basically this is going to be group 1, group 2, group 3, group 4, group 5, right? So now when we're arranging these, basically this means now by arranging these, we'll then therefore have an arrangement which will be 5 times 4 times 3 times 2 times 1, and that is basically 5 factorial, right? Okay, so we have that is our 5 factorial, and then now from there we're gonna multiply both the answer that we got in 1 and the answer we got in 2. So what did we get in 1, right? We got 3 factorial, so 3 factorial, then we're going to multiply this with 5 factorial, right? Now this is going to be the arrangement, right, of vowels following each other. Now you might think that we're done here, but nope, we're not done, because now the question asks us to find what? The probability, right? Now the probability of this now is going to be easy to find. So the probability of vowel following each other will then be this value, 3 factorial times 5 factorial. Now we're going to divide this with the total number of our arrangement, right? So the total number of our arrangement area, it was 7 factorial. So 7 factorial. Now let's see what we get with this one. So with this we get 3 factorial multiply by 5 factorial over 7 factorial. So that's what we get. So we get 1 over 7. So it is 1 over 7. Now, because of we have this, therefore, to find a probability that vowel will not follow each other, all we have to do right here is to take 1, is to say 1 and subtract this probability 1 over 7, right? Now this basically means now it's a complement, right? It means this part, this probability we're calculating right now is a complement of this, right? And to always get the probability of a complement, you always take 1, you always say 1 and then you subtract the other probability, which is what we're doing here. And then now if you press this into your calculator, it will then give you 6 over 7, and that will be our final answer. I hope this makes sense. I know it's long and I took longer and maybe I might have over explained it, but if you are still struggling with it, please make sure that you leave this in a comment. That way I'll be able to generate another video where I actually explain this complement rule, right? In the next videos, there's going to be a series of probability where I actually break it down, and when I get into this part, I will actually specifically explain to you how it all works, and you have multiple scenarios to see how it will all work. And I'm going to see you into the next videos. Cheers.